welcome to another episode of Andrew on the D. Today we're going over probability. Let's start. We'll start by defining an event. So an event is basically a well-defined occurrence. It's something that can happen. And so let's show an example. It's easier to understand. Let's say our event, we'll call the event A. And A is the event where we roll a 1 on a 6-sided dice. Then we can say that P of A, or the probability, so P stands for probability, of A occurring is 1 over 6. The reason why it's 1 over 6 is because the probability of any given event occurring is the number of favorable outcomes, like that, over the total amount of outcomes. So in our dice example, we have one favorable outcome, which is the case where we roll a 1, but there are 6 total possible outcomes. We can roll a 1, a 2, a 3, or 4, all the way up to 6. So that's why that's 1 over 6. Let's move on to unions and intersections. So often in probability we deal with not just one, but more than one event. So let's introduce a second event, and we'll call this one B, because that's next. And B is going to be, we flip a head. Flip heads on a coin. And right away, we all know that the probability is going to be 1/2. Now, what if I wanted to find the probability that, okay, first I roll my dice and I get a 1, and then second, I'm going to flip my coin and get a heads. How do I express this in probability kind of notation? So to do this, we use the intersection symbol. I'm going to write it out first. This is the intersection symbol. It's kind of like a lowercase n, but without the little stem here. And we're going to put A on this side and B on this side. And then we're going to ask for the probability of this. So this intersection symbol, you can kind of think of it as an AND statement. So read it as the probability, so probability here, of A and B occurring. So as you may have guessed, this turns out to be 1 over 12. And you would get this because this is 1 over 6 times 1 over 2. When the events are independent from each other, meaning the result of my dice roll does not affect how my coin flips, that means they're independent. And if they're independent, you can just simply multiply them together like this to get the probability of both occurring. What if I wanted to find the probability of just at least one of these occurring? So either I can roll a 1, or I can flip a heads and I'll be happy either way. To do this, we use, you may have guessed this, the union symbol. The union symbol is just backwards intersection. So think of this as an OR statement. We're asking the probability of A or B occurring. We're fine with either one. Both can occur, that's okay too. But we just need at least one. And this one's maybe a little more tricky to find out. You can help understand this by drawing a Venn diagram here. So let's draw that. Like that. And we have our box around the whole thing. So let's say this is event A over here, and this is going to be event B. So this common area in the middle is kind of the intersection area. That's why it's called intersection. This is the probability that both events occur. But what we're after is not that. We're after this whole area. The area where either A or B occurs. And how do we find this? Well, you could take the probability of A, which would be this circle here. You could take and add the probability of B, which would be, let me do this in a different color, blue. This circle. But you'll notice that, we have a bit of an overlap in the middle. And this is no good because now we've counted the middle twice. We only need to count it once. So we're going to subtract the intersection area. And this will give us our union. And I need to erase this wall, it's in the way. Like that. So this is the formula for union. it's going to be the probability of A occurring plus the probability of B occurring minus the probability that both occur. The reason why we minus is to kind of get rid of this overlap. We've kind of counted the middle area twice. We only want to count it once. So let's apply here. The probability of A occurring is going to be 1 over 6. The probability of B occurring is 1 over 2. And we're going to subtract our 1 over 12 here. And let's just do some fraction math. This becomes 2 over 12 plus 6 over 12 minus 1 over 12. It's going to be 7 over 12. So that's our answer. The probability that at least one of these events occurs is 7 over 12. Yep, that's about it for now. And join us next time when we talk about mutually exclusive and complementary events.